Here it is, the Communications Power Incorporated CP-2000 CB base station, 40 channels, upper sideband, lower sideband, and amplitude modulation. This radio was sold late 70s, early 80s, for about 4 years total, I think it was. And this is the completely designed and manufactured in the United States. And this company, CPI, was a company that also developed professional HF radios as well as military radios. And the result of this is that this is an excellent design in many aspects, which I'll show you. But it's also the best CB radio ever made. Then and now, there is no better CB station on the market, CB radio. And this beats everything, hands down, in terms of design and performance and manufacturing methods used. It's basically a professional radio made as a CB radio. Now, not too many of them were sold because they were incredibly expensive, and all the Japanese competition was coming up in those years, and CPI was not able to compete with that, because ultimately people buy based on price. Japanese radios weren't bad, not as good as this one, but they definitely weren't bad and good enough for CB. So that's the reason why this eventually lost out. So this is now a highly desired, highly sought after collector's item. And let's talk a little bit about what this radio can do. Now, radio obviously is PLL synthesized, which was one of the first ones. And I'll show you later inside, but the synthesizer in this radio is built up with discrete TTL chips. So if anything breaks down, you can still get those. There is no custom chips in this radio. 40 channels. And that's pretty straightforward. We got a front firing speaker, on-off switches here. We got 3 modes: amplitude modulation, single sideband beating lower sideband and upper sideband. We got a microphone gain. I'll show you that later when I test it on a monitor receiver. Now, microphone gain does have a compressor. This is something professional radios used to have, but you did not see it on CB radios. Now, I told you this was designed by a professional radio company, so they did design in a microphone compressor, and it drastically improves your talk power by about 6 to 10 dB. So that helps a lot to get through if the propagation is not perfect. Can be turned in, can be switched out, can be switched in. Microphone gain, usually half open is more than enough. We got a VSWR meter, and this is the calibration for that. Can give you quickly how that works. We go to AM, and I go to Cal, and I transmit. Oops, sorry. I gotta go to amplitude modulation for that, otherwise I have no carrier. And here I am calibrated for full scale. Then I go to read, and here I see my VSWR, my standing wave, which is 1 to 1.2. It's pretty good. We also got power, obviously. It's about 8 watt carrier, about 20 watt peaks right now. I did not mess with that, it's just how it came. It's a little bit higher than what the FCC allows, but the power amplifier here is heavily over-designed, so it easily can take that. It's equipped with a stripline transistor, not with one of those cheap Japanese transistors, but a real professional transistor that also was used for military radios, HF radios. Alright, so that was the VSWR calibration and readout. We got a clarifier obviously for sideband. Works kind of nice. When you have it at 12 o'clock position, it is exactly transceive. We got a squelch. Works pretty nice. It's a squelch without plopping. You know, the nasty plop squelches on Japanese radios. This one doesn't have that. And it opens quite nice, as you can see. There is an RF gain that works very nice. It works very linear. You see, it goes very proportional. It's not like those Japanese radios where when you turn it, everything is at the beginning and then after a while it does nothing anymore. This goes very gradual. Works very nice. And of course we got volume. Switches, I already discussed it a bit. This is VSWR read and calibrate. This is microphone compressor in and out. CB PA. PA means public address, so you can use the radio as a audio amplifier. Automatic noise limiter on off. Noise blanker on off. Now I'll show you a demonstration later of the noise blanker, especially in single sideband. That works extremely well. Actually, this is one of the better noise blankers I've seen on any radio, including ham radios. Actually, this noise blanker outperforms my $3,000 Icom radio, so that's quite something. So that's the front of the radio. Microphone is a normal 4-pin connector, nothing special there, so that's easy if you ever want to connect something else there. Let's have a quick look at the inside. Okay, I took off the top cover so you can have a look at the inside. Basically 1, 2, 3, 4, 5 compartments, 5 modules. This is the power supply, AC power supply, plus also the audio amplifier. This is mostly the synthesizer, frequency synthesizer, but also the single sideband balance modulator is there. And here you see the receiver exciter. Here is the crystal filter. It's a dual filter for both amplitude modulation for 6 kHz and single sideband for 2.5 kHz, 2.3 I think it is. So it has true narrowband single sideband like ham radios. It does not have this wide 5 kHz AM that all CB radios have nowadays, so they can pass both AM and single sideband. The result is for AM those are too narrow, and for single sideband they are too wide. This does not have that problem. You have a true 6 kHz filter for AM and a 2.3 for single sideband. The IF frequency is 10.2 megahertz. And here, I don't know if you can see it, are the 2 sideband crystals. So it uses individual sideband crystals, not some kind of vector shifted crystal, which is cause for instability. You don't have that problem here. And here you see the 2 crystals for the synthesizer mixer. Here are the TTL chips I was talking about. The programmable dividers are the 74160, a synchronous BCD counter, and those can still be easily found today in the HCT series, so that is not a problem if you ever need to replace anything. There's no custom chips in this thing. Everything can be still found today. Same for the audio amplifier. I think it's a TBA one. What is it? 120? Not quite sure. It's a bit dark in here, but that can still be found today. This is mostly the receiver section, but also the transmitter driver. And the transmitter power amplifier is in this module here, so it's not very visible. This is the input, this is the output. But, sorry, yes, this is the output, of course. This must be the ALC. But in any case, it has a stripline transistor. You can see the stud here. There's 2 of them, the driver and the final. And it's the same transistor that was used in military radios. The radio is capable of handling infinite VSWR, so you don't have to worry about blowing it up and do something wrong. Here is the control board. It contains the microphone amplifiers for the RF speed processor, as well as all the circuitry for switching and controls. This is the programmable, not programmable, it's the logic switch that gives off the logic code for the synthesizer, and that you can control obviously with the channel selector. It also codes the code for the display. Now this radio I have basically overhauled. I threw out a lot of the bad caps. For instance, these are two new caps in the power supply. They are 10,000 microfarads. The old one had two parallel of 5,000, but the newer ones have much more capacity in a much smaller size, so that's the reason why there was only one here instead of the two that you might be used to. Regulator integrated circuit, so this was replaced. I replaced a whole bunch of the electrolytics over there and some here. The other thing that obviously always goes out is the lights. These are not light bulbs, these are LEDs that I put in there, and they're not the nasty blue ones. They're the nice yellow, soft white they call them, just like the original light bulbs. So that gives the familiar yellowish kind of glow for the display, for the meters. Doesn't come out very well on the video, but it looks much nicer in reality. Maybe when I go back a little bit, maybe, yeah, this shows it better actually. Works very well, and it will last you forever. So that's the inside of the radio. Like I said, I can't show you this. This is a closed compartment, the power amplifier, but you can see the professional build of the radio. This is literally a professionally built radio. This is not some kind of cheap CB device. By the way, this is that noise blanker I was talking to you about. This is the circuitry for that. They put that on the vertical board there. Very well built. Let's test the modulation and frequency accuracy of the radio. For that we'll go to the dummy load. By the way, you can really hear the difference in noise. This is from the antenna, and this is the dummy load. You can see the noise, the internal noise of the radio is extremely low compared to the noise that's being received, which is proof of sensitive and good receiver. Anyway, we're on lower sideband here, we're on lower sideband here. We get about 15 watts. FCC allows 12, so in pretty good shape. We're at 27.384.99, so the Yaesu and the CP-2000 disagree 10 Hertz between each other, which is extremely good. The Yaesu has the high stability option, so that should be within 1 ppm, so we're doing pretty good there. 1, 2, 3, 4, 5. Modulation sounds excellent. Let's go to the upper sideband here and do the same on the Yaesu. Got the same power level, same modulation. Now this is with compressor in. This is compressor out. It's a little bit less punch. 1, 2, 3, 4, 5. As you can see, the microphone gain is half open, which is actually more than enough. You see, you don't need more than half. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You don't need more than half, but anyway, let's go to amplitude modulation and see what we get there. Amplitude modulation, carrier power. Hang on, this is still, there we are. We got about 5 watt carrier and about 15 watt PEP. This meter is kind of nice because it really shows PEP. For instance, if I turn down the microphone gain, here you can really see my carrier. It's exactly in disagreement with the bird. And once I start modulating, I see my PEP level, which is very good. 1, 2, 3, 4, 5, and the modulation of course sounds excellent. 1, 2, 3, 4, 5. Jesu modulation. Jesu amplitude modulation is not great. Ham radios never sound good in AM. So let's go to lower sideband and see how that sounds. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is a right on frequency. Go to the upper sideband. As you can see, the clarifier is exactly at the 12 o'clock position, and that is the way it should be. So when you put the clarifier here in the middle, then your transmitter and receiver frequency is identical, and if the other station is off frequency, you just tune until you can hear him properly. So that's the modulation for this radio, and power. It's very good. Alright, this is just something I had to show you. I have this cheap Chinese LED desk lamp. When I turn that on, my radio is completely blasted with noise. Cheap Chinese LED. But look what happens when I turn on the noise blanker. This noise blanker actually is capable of getting rid of that noise completely. This is totally unbelievable. Not even my ham radio can do that. This radio has the best noise blanker I have ever seen in my life. A noise blanker that actually blanks noise. That's better than on my $3,000 ham radio. Very impressive. Just a quick demo of the amplitude modulation envelope for this radio. We have it in AM mode. We have a 30 dB attenuator between the radio and this oscilloscope, terminated in 50 ohms. One, two, three, four, five. 1, 2, 3, 4, 5. As you can see, there is no overmodulation, no flat topping. The automatic gain control of the modulator, AM modulator in this radio, is just perfect. Very, very good amplitude modulation. Now the peak, if you look at the scope, it's 2.6 divisions at half a volt, so the peak-to-peak value is 2.6 volts for this signal. Of course, that is the result of 30 dB attenuation. If you do the math into 50 ohms, you will see that the radio puts out 17 watts PEP in amplitude modulation. So that is a very good number, and that actually corresponds pretty good with the wattmeter here. As you see, it goes a little bit over 15 watts, exactly what the real power is. So that's nice of this radio. It both shows the carrier power as well as the peak envelope power during modulation. Excellent. We see the back side of the radio. Pretty straightforward. We got a SO239 antenna connector. We got fuse. We got AC power. As you can see, AC is a bit of a weird one. This is the connector. It's not standard, but this is what they used. This is the same connector that was used in the 70s and 80s for Hewlett-Packard test equipment, professional stuff, and for whatever reason they also use it for these radios. It's they're hard to find, these power cables. I've seen them go for $40 on eBay, but it is included for this radio, so that's not going to be a problem for you. This is the switch between headphones or speaker. Speaker goes here, headphones go there. This is a output for an external frequency counter. I understand that CPI actually did sell one themselves, but this is where that would hook up, and then you can see your actual transmitted and received frequency. ID plate and serial number. That's it, pretty straightforward. Alright, so that was basically it. The Communications Power Incorporated CP-2000 from the early 1980s, late 1970s. This particular one is in almost like new condition. It's very nice. The front is pristine, knobs are very clean, meters are without any scratches, grill looks good, switches work fine. This radio is just like it worked when it came from the factory. The microphone is not original, but it's a Raycall Acoustics, a high-end microphone, and it works very well on this radio. The microphone is also like brand new. And as you see, it works fine. Thank you for watching this video. Lower sideband. There is some propagation today. It's not that great. Upper sideband, nothing there. Back to lower sideband.
104 Connecticut, you copy 627 Central Indiana?
Clarifier.
Yeah, we just spoke to you, Randy. Okay, just copying you very well over here in Indianapolis, Indiana. Operator 10, Kilo Archer November. They call me 80 proof around here to Circle City there, Central Indiana. QSL? Okay, 627, we're QRZ.
Let's look at amplitude modulation. Not too much going on today. Got a bit of skip. Back to single sideband.
Try it again there, over.
Sounding good, 747. Sounding good this morning. Just gonna let you know, radio sound choice coming down here in the Smoky Hills of Tennessee.
177. Hope the family's good. Hope everything's good for you. 299.